Hi, I've been teaching freshman physics this semester, and I noticed something in the textbook that we've been using, which is Serway and Jewett, that reminded me of a puzzle that had intrigued me at various points as a student. So let me share this with you. So this is something that I first learned about from my 8th grade science teacher a long time ago, and it's how to find in practice the center of mass of something like this ruler, this meter stick. And the instructions are that you should take it, you should put the index finger of each hand on opposite ends of the stick so that it's resting stably and not tipping over. And then you should push your hands in gently. And then your hands will meet right under the center of mass of the object, which in this case you can see is the 50 centimeter mark on this ruler. And just to show you that this works in general, let me take this bit of Play-Doh and attach it to one end of the ruler. This is my right hand side, and let's do this again. So now the center of mass will have shifted towards the right end. I don't have to be terribly careful about exactly where I put my fingers initially, as long as the ruler is stable and not tipping over. And I also don't have to be terribly careful about how much force I exert on each hand. And you'll see that this process is not continuous. So usually one finger will be stuck to the surface of the ruler and the other one will be sliding, but then they switch. So one finger will become unstuck, and the other one will become stuck, and so on, until finally, in this case, my hands have met under the 63 centimeter mark, which is a new center of mass. And I know it's a center of mass because it's not tipping over. Let's do this one last time. So now I'll take the Play-Doh and I'll attach it to the left end of the ruler. And let's do this again. So it's stable initially. So you see now it's my right hand finger that's sliding and the other one is stuck. But then it becomes, at some point my left finger becomes unstuck. Then it switches a few times, and then finally my hands meet under now it's this 37 centimeter mark. So why does this work? So I remember when our 8th grade teacher told us about this, that I was puzzled. And then a couple of years later in high school, I sat down more than once and I tried to apply Newton's laws of motion to this problem to see if I could understand why the hands always met under a center of mass. But I couldn't come up with a fully satisfactory answer. And what's particularly confusing is that, as I've emphasized, this is not, in practice, this is not a continuous process. So usually one finger is sliding and the other one is stuck. And then you'll switch which finger is stuck and which one is moving with respect to the surface of the ruler a few times before you find the center of mass. And then a couple of weeks ago, I found discussion of this process in the beginning of chapter 12 of volume 1 of Serway and Jewett. But they leave this as a puzzle. As far as I could tell, they don't give an explanation for why this works. And this reminded me that a couple of years ago, maybe 2-3 years ago, so a long time after I first heard about this, I was no longer actively thinking about this. I was not consciously thinking about this problem, but for some reason, an intuition came to me all of a sudden that I could explain why this worked. So let me put this to you as a puzzle. Can you, using Newton's laws of motion, explain why in this process your hands must meet under the center of mass of the ruler? And if you're interested in this, I will attach to this video my written explanation of why this works, so you can check this out when you want.